All right, so number 9, we want to find a counterexample. So something that doesn't work to disprove these following. The first says if n is a natural number, then n plus 5 divided by 5 is equal to n plus 1. Now, we can use our calculator to verify and check these, or we can do it by hand. I think it's faster to see it with the calculator. I'm just going to put the left side in Y1, the right side in Y2, just to show you. I don't think this is true for any case, and then we'll be able to pick which one of these statements best match. But just so you can see, I'm going to go to Y equal, clear out what I have, and then I'm going to do n plus 5 divided by 5. So, and we have to do x in the calculator, so I'm going to say x plus 5. Same thing, just a variable. So x plus 5 divided by 5. All right, so this is one side, and now I'm going to go down to Y2, and I'm going to do x plus 1. That's going to be the other one. And I want to look at the table, so I'm going to do second graph, and see if these two are ever equal. Okay, so starting with 1, that's the first natural number. All right, so I'm looking at these two values, Y1 and Y2, and as I go down these columns, you can see that it's not equal anywhere. I think the only place it might be equal is at 0, but 0 is not a natural number. Natural numbers start from 1 and count all the positive whole numbers. So when dealing with natural numbers starting at 1, you can see that these two columns over here are not equal anywhere. And the bigger we get, the further apart these two numbers get. So which one of these statements say that any natural number n that is less than 5 can be used as a counterexample? That is true. Any natural number n can be used? Yes. That's more true. Okay. Any natural number n that is not equal to 5? Nope. And it says any natural number n greater than 5. So any natural number, any number that we use, any whole positive number that we use can be used as a counterexample, because you can see in this table none of these are equal. Okay, now it says choose the most general case. So it says given a counterexample for n plus 4 squared equals n squared plus 16. So this is that general freshman dream I think that people want to do. That I'll just give two numbers. Say 2 plus 3 in parentheses squared. We want that to be the same as 2 squared plus 3 squared. Okay, so this is just an idea. Like if you see a square, most people want to just square both terms. But if I work this out, I'll show you that it's not the same. You could also do it with the calculator by plugging in the formulas and seeing for any natural number you pick. But I'm just going to show you this example. Order of operations says you would do parentheses first. So I would add these and get 5. And then I would square 5. And we would get 25. Okay. Over here, if you squared each of these, you would get 4 and 9. Because 3 squared is 9. If you add those, you get 13. And you can see that this is not equal. So what this property wants you to see is that if you have parentheses with two separate terms squared, it is not equal to just squaring both of them individually. So again, any natural number, and let me also show you with the calculator while we're here. Let me go to y equal. I'm going to clear this out and clear this out just so you can see furthermore. In parentheses, we're going to do x plus 4 and then square it, And then in the second equation, we're going to do x squared plus 16. So x will be changing different numbers. If we do second graph to see the table, and we'll just look at the second two columns. This is the first column, x, is just showing you the number that they plug in, and over here we're getting the results. So as you can see, none of these pairs are the same, and as we get bigger, they get bigger, and they're not closing the gap very much. So any natural number n less than 4, any natural number, yes, any natural number can be used as a counterexample.